Dive deep into the hidden forces behind love and desire in the science of attraction. A captivating narrative that blends neuroscience, psychology, and human connection. Follow Dr. Elena Rossi as she unravels the brain's secrets behind chemistry, first impressions, and the future of love in the digital age. This video brings science to life with emotion, curiosity, and groundbreaking insight into what truly draws us together. Welcome to Echoes of Mind. Don't forget to like, share, and subscribe. Let's get started. Chapter 1: The Spark of Curiosity. Dr. Elena Rossi paced the polished floor of the Kronos Institute's atrium, her mind racing with questions she'd wrestled with since her first neuroscience lecture. What made hearts flutter? Why did two strangers lock eyes across a room and feel an inexplicable pull? She dedicated her career to understanding the phenomenon of attraction, determined to uncover its secrets. Tonight's gala promised more than celebration. It was an opportunity. The atrium was awash in warm light, its honey-colored columns framing clusters of people engaged in animated conversation. Elena observed them like a scientist studying a rare species in its natural habitat. She noted the subtle micro-expressions: a quick upturn of the lips, broadened pupils, a slight lean toward another person. Each gesture hinted at neural processes firing deep within the brain. Her research assistant, Jordan, approached, clutching a tray of champagne flutes. "Ready for tonight?" he asked, voice low. Elena smiled, but her eyes remained focused on the scene. "More than ever, I've gathered enough preliminary data to form a new hypothesis, one that ties pheromonal signaling to visual perception in ways we haven't quantified before." Jordan raised an eyebrow. "You really think pheromones aren't just myths?" "There's mounting evidence," Elena replied. "Even humans emit chemosignals that communicate emotional states. Fear, happiness, even attraction itself. We've measured compounds like androstenedione in sweat and seen correlated activity in the hypothalamus. Tonight, I want to see if we can detect behavioral changes in response to calibrated scent dispersal." As the orchestra swelled with a lilting string quartet, Elena moved closer to the event's centerpiece, a sleek silver dispersal device tucked behind a sculptural column. Jordan joined her, handing over a small vial of synthetic pheromone. They had engineered the solution to mimic the average composition found in male sweat during moments of excitement. Their plan was simple: release the pheromone into the air near random pairs and discreetly record facial expressions, heart rate changes, and social engagement. Elena glanced around for her first volunteer pair. Her gaze landed on two colleagues, Dr. Malik Patel and neuroscientist Sophie Wong, laughing by a crystal fountain. "Perfect." She discreetly triggered the dispersal mechanism. Within seconds, a faint, musky scent diffused through the marble hall. "Did you smell that?" Sophie asked, wrinkling her nose with playful gusto. Malik leaned in, a hint of something familiar, like after a workout. Elena checked her tablet. Heart rate's up by 4%. Increased mutual gaze. Microsmiles. "Yes, it's responding," Jordan whispered. "We're onto something." But Elena's mind raced beyond the data. Each microreaction carried profound implications. The unconscious dance of chemistry, biology, and perception that orchestrated human connection. Later, as she reviewed the footage in her lab, Elena paused on a frame capturing Malik's pupils dilated at the moment the pheromone puff reached him. Her pulse quickened too, as if, in that instant, the science of attraction had extended its tendrils to her own mind. She touched her fingertip to the screen, tracing the path of his gaze toward Sophie. "So simple," she murmured, "and yet so powerful." Elena knew this was only the beginning. Beneath each smile, each heartbeat, lay a complex tapestry of neurotransmitters, hormones, and subconscious judgments. Over the coming nights, she would follow the thread of attraction from the flicker of dopamine in the ventral tegmental area to the really. Chapter 2: The Chemistry of First Impressions. The laboratory buzzed with quiet energy as Dr. Elena Rossi adjusted the electrode placement on her subject's scalp. Today marked the second phase of her study, investigating how the brain reacts during a first encounter. The Kronos Institute's neurosensory lab had been transformed into a comfortable mock cafe setting, complete with soft lighting, ambient noise, and the faint scent of roasted coffee beans. Everything had been designed to simulate a casual first meeting. Across from Elena, seated behind the one-way mirror, Jordan monitored the EEG readings while two strangers, participant A and participant B, sat down for their first interaction. Elena whispered into her headset, "Let's begin the 5-minute conversation window." The two volunteers began talking, their body language cautious but polite. Within moments, Elena saw what she was looking for. "Look at that," she murmured. "Increased beta activity in the prefrontal cortex and a dopamine spike." Jordan nodded. "It correlates perfectly with mutual eye contact." First impressions, Elena knew, were more than gut instinct. They were a lightning-fast evaluation processed in milliseconds. As soon as someone entered our visual field, the brain engaged in a rapid-fire analysis of facial symmetry, skin tone, voice quality, scent, posture, and even perceived genetic compatibility. "There's a concept called thin slicing," Elena said to Jordan later. "We make snap judgments from just a few seconds of interaction, and often they're surprisingly accurate." But attraction wasn't simply about aesthetics. Behind every impression was a complex interplay of chemistry and cognition. As the participants continued talking, Elena watched the subtle shifts. The man leaned in slightly, the woman tucked her hair behind her ear, classic signs of interest. The team had also introduced oxytocin nasal sprays to some pairings and placebos to others. When participant B had received the oxytocin spray, his conversational tone was warmer, more engaging. His partner mirrored his body language, another sign of unconscious rapport. The EEG showed deeper limbic system activity, especially in the amygdala, hippocampus, and nucleus accumbens. Elena explained to a student observer nearby, "These are the areas involved in emotional memory and reward processing." First impressions literally leave a chemical mark on the brain. Later that evening, Elena reviewed the playback, comparing pairs that clicked with those that didn't. In nearly every case, compatible pairs showed increased synchrony, matching speech cadence, posture, and expressions. "It's as if their brains were dancing," she noted. Jordan looked up from his notes. "You ever wonder what our brains looked like the first time we met?"
Elena chuckled.
"Probably full of skepticism and caffeine. And now," she paused, "now they're dancing too." What lingered after a first impression wasn't just visual or verbal. It was an imprint, a neural snapshot stored in memory and reinforced with each future encounter. Elena realized that the first few seconds of meeting someone could hold the weight of entire chapters yet unwritten. Chapter 3: Pheromones and Subtle Cues. The early morning light streamed through the glass-paneled dome of the Kronos Institute's biology lab, casting a golden glow over microscopes, vials, and charts. Dr. Elena Rossi stood hunched over a workstation, her gloved hands carefully preparing a sample under the watchful gaze of her research assistant, Jordan. Today's focus: decoding the role of pheromones in human attraction. "You really think we can track something as ancient and invisible as a scent trail through modern behavior?" Jordan asked, half skeptical, half intrigued. Elena smiled, holding up a sample dish. "Nature has always left trails. We just haven't always known where to look." They were analyzing skin swabs from volunteer participants who had experienced strong Jordan leaned over the monitor. "But what if it's placebo? People smell something, think it means something, and then act accordingly. That's why we're double-blinding everything," she replied. "Volunteers have no idea whether they've been exposed to synthetic pheromones or a neutral control. But even before they consciously register it, their brain does." She gestured to another screen displaying fMRI brain scans. "See this? Activation in the hypothalamus and the orbitofrontal cortex after exposure. That's instinct and reward processing at work." Later that afternoon, they invited a new test pair into the scent-controlled room. The air was meticulously filtered. A tiny vial of synthesized androstadienone was released beneath a disguised diffuser, programmed to mist the area between the pair midway through their conversation. The results were near instant. The male participant leaned closer, unconsciously mirroring the woman's gestures. Her pupils dilated slightly, they laughed more, and the conversation tempo quickened. "Fascinating," Jordan whispered behind the observation mirror. "It's not just smell," Elena said. "It's a silent signal, a message encoded in molecules saying, 'This person might be genetically compatible.'" She explained that pheromones travel through the olfactory system to the vomeronasal organ, VNO, a vestigial structure still somewhat functional in humans. The VNO links directly to brain areas governing emotion and sexual behavior. "But what about culture?" Jordan asked. "Surely social norms override biology?" "They influence it, yes, but in those first few seconds, when the logical brain hasn't caught up yet, chemistry has the first word." Elena recalled a study from the University of Bern, where women preferred the scent of men with immune system genes different from their own, potentially enhancing offspring viability. "Pheromones may not determine who we love," she continued, "but they could nudge us toward someone before we even understand WH. Chapter 4, Neural Pathways to the Heart. The brain is not just where we think. It's where we feel, where we fall, and where the roots of attraction take hold. Dr. Elena Rossi sat in the Kronos Institute's Neuroimaging Center, reviewing scan after scan of couples' brains. Each colorful image represented a story, a spark, a moment when two people connected. The goal of today's work was to map out the neural highways responsible for love, lust, and longing. She and Jordan had begun a new study using fMRI scans taken during simulated dates, brief, structured encounters between volunteers, captured in real time with neurofeedback. "Okay," Jordan said, guiding their next pair into position. "Participants 12 and 13 are ready for their interaction window." The participants lay in side-by-side imaging chambers, eyes viewing each other through screens. Using a split-feed camera system, their facial expressions were visible while stimuli like voice recordings, photos, and flirtatious questions were introduced. As the conversation began, Elena observed changes almost immediately. Dopaminergic activity spiking in the ventral tegmental area, she noted. "That's the reward system kicking in. And look here," Jordan pointed, "activation in the caudate nucleus, same region associated with goal-directed behavior and obsessive thinking. Classic early-stage attraction," Elena nodded. But there was more. When one participant smiled, the other's mirror neuron systems lit up. It was empathy in motion, one brain echoing another. As the experiment progressed, other patterns emerged. The anterior cingulate cortex showed signs of increased blood flow, a region associated with emotion regulation and decision-making. Meanwhile, the insula, tied to body awareness and emotion, subtly pulsed with activity. "It's a neural orchestra," Elena whispered, each region chiming in, harmonizing in real time. The most striking activation came from the nucleus accumbens, one of the brain's primary pleasure centers. This area responded not only to physical attraction but also to anticipation, the craving to know more, to be closer. Later that afternoon, Elena examined brain patterns from participants who reported instant chemistry versus those who felt neutral. The difference was dramatic. Chemistry wasn't just a metaphor, it had a measurable neural signature. Jordan leaned over, sipping his coffee. "What about love over time? Do these circuits fade? Or do they adapt?" Elena smiled. "They adapt. In long-term bonds, the brain relies less on dopamine-driven infatuation and more on oxytocin and vasopressin. It's like trading a firework for a hearth." She pulled up older scans from a study on long-term couples. The amygdala, often associated with fear and threat detection, was less reactive. These couples saw each other not as a risk, but as a safe haven. Their brains released serotonin and oxytocin, building trust and calm. That night, as Elena sat alone in the lab, reviewing the patterns, she felt a strange warmth. These weren't just graphs and images, they were echoes of the most human parts of us. The pathways between brain and heart weren't linear, but looped and complex, bending towards safety, joy, and the need to be known. She made a note in her research log. "Attraction is not just instinct, it's architecture, a living blueprint of emotion shaped by evolution, experience, and the quiet whisper of neurons in sync. The lights dimmed, and the monitors hummed in the quiet. Tomorrow, more scans, more stories. But tonight, Elena saw clearly, love leaves a trail, and it leads straight through the neural corridors of the heart. Chapter 5, Oxytocin's Embrace. The hum of soft jazz filtered through the Kronos Institute's conference hall as Dr. Elena Rossi prepared for her presentation. Her topic today, oxytocin, the so-called love hormone. But Elena knew it was more than a buzzword. It was the biochemical thread that wove strangers into soulmates, friends into confidants, and fleeting attraction into enduring connection. She stepped up to the podium, her slides glowing behind her like illuminated secrets. Oxytocin is not about euphoria, she began. It's about bonding, trust, safety. Without it, human relationships crumble. In the audience sat couples who had volunteered for her long-term attachment study. They were here to learn what made them feel close, neurologically speaking. Jordan stood in the back with a tablet, monitoring real-time feedback from a wearable device tracking oxytocin levels through saliva markers. Elena nodded at him before pressing play on a video. On screen, a man held his newborn for the first time. Tears welled up as he whispered to the tiny human in his arms. At the same moment, his oxytocin levels surged. Elena turned back to the audience. This is what happens in romantic love, too. Eye contact, a shared laugh, a gentle touch. Each moment triggers a neurochemical loop. Oxytocin reinforces the connection, making us feel safe enough to be vulnerable. After the lecture, she and Jordan returned to the lab. On the whiteboard, she drew the hormones pathway, from the hypothalamus to the posterior pituitary gland, then into the bloodstream. People think oxytocin is all hearts and flowers, Jordan said, but it also makes us protective, possessive even. Exactly, Elena agreed. It's the molecule behind both cuddling and jealousy. She pulled up a case study involving 2 participants from a recent experiment. They were strangers at first, introduced in a controlled setting where they had to complete a cooperative task. During moments of success, oxytocin levels RO. Oxytocin builds tribes, Elena said, and tribes protect their own. That evening, Elena and Jordan reviewed data from couples who had been together for over 10 years. What struck them was not intensity, but consistency. Their oxytocin responses weren't fireworks, they were steady embers. These couples may not have the dopamine highs of new lovers, Jordan said, but they show synchronized oxytocin pulses even during mundane interactions. Like cooking together, Elena smiled, or folding laundry. She remembered her own parents. They rarely showed grand affection, but every evening, her father would make tea just the way her mother liked it. Small rituals repeated over time, neurological glue. Later that week, Elena introduced a new variable into her lab trials: conflict. Couples were prompted to argue about something real. Predictably, oxytocin dropped during tension, but when partners made amends through touch or humor, levels rose again. It's not about avoiding conflict, Elena recorded in her journal. It's about recovering from it together. One night, long after the lab had emptied, Jordan lingered. He placed a small box on Elena's desk. Inside was a mug with the words, "Safe spaces begin with you." Elena looked up. "What's this?" He shrugged. "Thought you'd like something that reminds you of your work. And of us." For a moment, no data mattered. No charts. Just the warm rush of something unmeasurable, familiar, calming. And maybe, just maybe, oxytocin whispering through her bloodstream. She made one last note before shutting down her computer. Attraction begins with a glance, but love is chemical courage, the biological invitation to stay. Chapter 6, the role of voice and touch. The quiet hum of the sensory lab was broken only by the rhythmic ticking of a metronome. Elena sat at the observation console, reviewing the day's experiment. A series of interactions focused on 2 often overlooked components of attraction: voice and touch. In many ways, she had told her graduate students that morning, the voice is the first physical touch between strangers. She wasn't being poetic. Her research showed that vocal tone could trigger neural responses similar to physical contact. In today's trial, participants would speak to each other in various tones and volumes while being monitored for physiological reactions, heart rate, galvanic skin response, and subtle facial muscle movement. Participant A's voice had a gravelly timbre, low, confident. Participant B's pulse quickened after the first greeting. Elena zoomed in on her facial muscles. Tiny smile. Her eyes widened a fraction. Confirmation, Jordan whispered beside her. Vocal tone alone induced an autonomic response. Elena nodded. Now let's layer in touch. The experiment's second phase involved controlled, non-romantic physical contact. A brief hand touch, a shoulder pat, a shared object passed from one participant to another. The team measured oxytocin spikes, dopamine activity, and areas of the brain involved in somatosensory processing. When the participants shook hands, just 3 seconds of contact, the data lit up. Insular cortex activation, Elena noted. They're processing the touch as emotional, not just physical. She recalled a study from MIT suggesting that even brief skin-to-skin contact could increase cooperation in team tasks. The reason? Touch signaled safety. Evolution wired us this way, Elena told the team. Touch was reassurance. In tribes, it meant protection. In lovers, it means belonging. Later that evening, Jordan walked Elena through their vocal dataset. They had captured subtle fluctuations in pitch, breathiness, and pacing. Women tended to prefer slightly deeper voices, he said, but not too deep. It needed warmth, not threat. Elena added, men responded more to variation, playfulness in tone. A monotone, even from an attractive face, dampened interest. They discovered that synchrony, matching tone and pace, was the strongest predictor of mutual attraction. It's like dancing with your voice, Elena mused. Later, Elena recorded her reflections into her journal. Voice is vibration, touch is pressure. Both bypass logic and speak directly to the limbic brain. They're ancient tools of intimacy, honed over millennia. She thought about her own relationships. A voice message from a loved one had once brought her to tears. A friend's hand on her shoulder had calmed her more than any words. Maybe, she whispered to herself, we fall in love not with faces, but with the way someone's presence feels in the air between us. Back in the lab, the last scan of the day flickered on screen. The data was clear, voices and touches, when genuine, ignited more than attraction. They nurtured emotional security. And perhaps Elena thought that was the most attractive thing of all. Chapter 7, Cultural Codes of Attraction. The Kronos Institute had opened its doors to a special panel that week. Anthropologists, psychologists, and sociologists gathered to discuss how culture shaped romantic preference. Elena stood before a rotating globe, pins stuck in key regions of the world, her notes color-coded by continent. She turned to her students. What's considered attractive in one culture can be completely overlooked in another. Attraction is both biology and belief, shaped by centuries of ritual, myth, and tradition. To demonstrate, she projected side-by-side images of couples from Japan, Nigeria, Brazil, and Finland. Some were laughing, others posed formally, yet all were bound by unspoken norms about posture, gaze, even physical closeness. In East Asian cultures, she explained, modesty and restraint are often romanticized. In contrast, Latin cultures value expressiveness and physical touch. Neither is more correct. They're reflections of what each culture sees as safe, admirable, or passionate. Later in the lab, she reviewed cross-cultural data comparing dating app preferences. In Scandinavian countries, profiles that emphasized independence scored higher. In South Asian countries, family values and education were emphasized. In the US, humor topped the charts. Jordan walked in holding a printout. Here's the voice preference study you wanted. Turns out pitch preference varies by culture, too. In some regions, men favor higher-pitched voices. In others, deeper, more grounded tones signal trust. And look here, Elena said, pointing to another chart. Facial symmetry is almost universally preferred, but its meaning differs. In some cultures, symmetry suggests health. In others, it's linked to spiritual balance. She turned to the whiteboard and wrote, "Cultural filters equals evolution plus symbolism." Elena had recently interviewed couples in intercultural relationships. Their insights were profound. One pair bonded over food rituals, another over shared second languages. What began as fascination often evolved into deep admiration, not despite their differences, but because of them. Romantic attraction is partly about identity, she told her students. Sometimes we're drawn to those who mirror our world. Other times, we're drawn to those who expand it. That evening, she rewatched a documentary on courtship rituals in Papua New Guinea. Men sang love songs in falsetto to women seated in elaborately painted circles. Though different from modern dating, the purpose was the same: to signal intent and devotion. She scribbled a note in her journal. The methods vary, but the message is constant. See me. Choose me. During a follow-up panel, a guest lecturer challenged her. If attraction is so cultural, how can we study it scientifically? Elena replied, by studying both the constants and the context. Oxytocin still flows. Dopamine still fires. But culture frames when, how, and why those processes are triggered. She shared the story of a Maasai woman who described falling in love after receiving a handmade beaded necklace. In her world, that was the highest symbol of romantic commitment. To her, it felt like fireworks, and her brain likely responded the same way someone else's would to a first kiss. Back in the lab, Jordan handed her a cup of cardamom tea. So, love is global, but filtered locally?
Elena Laugid.
Exactly. Love speaks every language. You just have to learn the dialect. She watched the sunset that night from her office window, thinking of all the unseen rituals happening across the globe. A shared meal in Seoul, a poem in Tehran, a dance in Lagos. Chapter 8, When Attraction Turns Toxic. The lab had always been Elena's sanctuary, a space of discovery, logic, and insight. But on this particular afternoon, a heaviness lingered in the air. Today's subject was less romantic, more sobering. The dark side of attraction. When desire crossed boundaries, when chemistry defied ethics, when what drew people together also tore them apart. She began the session by asking her class, what happens when the very things that attract us become weapons? Silence, then murmurs. Jordan flipped the projector to a slide. Attachment, obsession, and abuse, the neurology of toxic love. Elena explained, in healthy attraction, dopamine and oxytocin reinforce pleasure and bonding. But in toxic dynamics, those same chemicals can trap individuals in cycles of dependence. She walked over to the whiteboard and drew a loop. Pleasure, withdrawal, reconciliation, repeat. This pattern mirrors addiction. The team had recently run a study using functional MRI on individuals in emotionally abusive relationships. When shown photos of their partners, even ones who had harmed them, their brains lit up in the same reward centers activated by substance abuse. Love can hijack the brain, Elena said, especially when paired with inconsistent reinforcement. One case stuck with her. A woman named Maya, who had volunteered to share her story anonymously. Her partner alternated between adoration and cruelty. During highs, Maya's brain flooded with oxytocin. During lows, her cortisol spiked. She became chemically conditioned to crave his approval, even as he destroyed her self-worth, Elena noted. They reviewed recordings of interviews. Maya spoke softly, fingers trembling. When he left, I felt like I couldn't breathe, like I'd lost part of myself. Jordan lowered the volume. It's terrifying how the brain can blur pain and love. But it wasn't just romantic relationships. Elena shared data on parasocial attraction, obsessive attachments to celebrities or influencers. The reward systems reacted similarly. Obsession is attraction without access, she explained. It simulates connection, but offers no reciprocity. Later that evening, Elena sat in her office, reviewing journals of abuse survivors. One entry read, "He made me feel like the only person in the world, and then like nothing." She stared at those words. "This isn't just psychology," she whispered. It's chemistry used against us. She pulled out a study showing elevated dopamine levels during trauma bonding phases. Another noted that cortisol dysregulation from chronic emotional stress could desensitize the brain's alarm system, making toxic behavior feel normal. The next day, she presented a framework for identifying toxic attraction in clinical settings. Neural scans, hormonal markers, behavioral flags. Jordan raised a crucial point. If we can detect these patterns early, can we intervene? Elena nodded. That's the goal. Education, therapy, and support systems must evolve to account for the biology behind emotional entrapment. At the close of her lecture, she shared a quote. "Not all bonds are meant to hold us. Some are meant to be broken." As students filed out, Jordan lingered. "You okay?" he asked. She gave a tired smile. "I just wish more people understood this. That being drawn to someone isn't always a sign you should stay." That night, Elena added a line to her personal research notes. "Attraction is a force, but forces can heal or harm. The key is knowing the difference." Chapter 9, The Digital Age of Dating. The glow of screens had replaced candlelight. Algorithms now played matchmaker, and emojis had become modern love letters. As Dr. Elena Rossi scrolled through the latest research data in her office, she pondered how attraction had adapted in a world of swipes, texts, and digital chemistry. Online dating has changed the game, she told her students during a seminar. But the biology hasn't changed. The human brain still responds to cues of attraction, even if those cues are pixelated. Her research team had launched a study examining dating app interactions. Participants wore biometric sensors while using apps like Spark and Matchmind. The data revealed real-time spikes in dopamine, particularly during matches or messages from high attractiveness profiles. But here's the catch, Elena said, pointing to the charts. There's also a crash when expectations don't meet reality. Ghosting, mismatches, and ambiguity trigger the same brain regions associated with social pain. Jordan chimed in. It's digital gambling. Each swipe is like a slot machine pull. Maybe the next one will be the one. In the lab, they recreated a virtual dating simulation. Volunteers interacted via avatars that mimicked their real expressions and tone. Even in digital space, the brain responded to perceived emotional warmth, voice inflection, and timing. We may be online, Elena explained, but our limbic system is still offline, running on instinct and pattern recognition. The study also explored text chemistry, how language, emoji use, and response time affected attraction. They found that quick responses with varied tone and emotional language built stronger connections. Dry, delayed replies dampened interest, even in visually appealing profiles. Elena recalled her own brief experience with online dating. I once unmatched with a man because he said K instead of okay. It's irrational, but that's how subtle these signals are. She shared another finding. Participants judged profiles within 0.7 seconds. Faster than the blink of an eye, she noted. We're making biological judgments on digital platforms. As evening fell, Elena and Jordan reviewed a separate dataset, video calls. During virtual first dates, mutual gaze and synchronized smiles were rare but powerful indicators of attraction. Even through webcams, oxytocin levels rose when people felt truly seen. But what about deception? Jordan asked.
Filter, curated bio, AI générated message.
Elena nodded.
The brain still reacts, but the consequences are different. Mismatched expectations can lead to emotional dissonance, a disconnect between what the brain anticipates and what it experiences. To address this, her team began working on a new tool, an empathy-driven AI dating assistant that offered real-time cues about tone, response patterns, and emotional alignment. Elena presented the prototype at a tech and neuroscience conference. We're not trying to replace intuition, only enhance it, she told the crowd. Our goal is to help people navigate attraction with insight, not illusion. In her journal that night, Elena wrote, technology can connect or confuse, but at its best, it mirrors the same needs we've always had, to be known, to be chosen, to be loved. And as she watched her own phone light up with a message from someone she hadn't seen in a while, she smiled. Maybe some signals, no matter how digital, still felt real. In a follow-up study, participants were introduced through bios without photos. They connected through voice, shared values, and story exchanges. After a week, they met in person, and many reported deeper attraction than with app-based encounters. It's a shift, Elena reflected, from visual first to values first. Perhaps the future of attraction isn't more stimulation, but more depth. She included work from philosophers and poets, blending art with neuroscience. There's a reason love can't be fully explained in a lab. It's both electrical and eternal. During a break, Jordan handed her a note, folded like an old-school paper airplane. Inside was a line scribbled in his looping script. The data brought us together, but the story kept us close.
Elena Smilet.
In all their searching, perhaps this was the greatest revelation. That the future of connection wasn't just science. It was story, empathy, and intention. In her final slide, a single quote appeared: "Love is not a formula. It's a dialogue, ongoing, imperfect, real." As the audience rose in applause, Elena felt the resonance of every moment she'd studied, every neuron she'd mapped, and every gaze she'd recorded. The science of attraction had brought her to the edge of what could be known. Beyond that, that was where the human heart still reigned. Chapter 10, Beyond Biology, The Future of Connection. The Kronos Institute's auditorium buzzed with anticipation as Elena prepared to deliver her final lecture in the year-long series. A large screen behind her displayed a split image, one half showing a glowing neural network, the other a pair of clasped hands. It was time to look forward, beyond the data, beyond hormones, to what the future of human connection might hold. We've explored the biology, Elena began, but the science of attraction is not just about what is, it's about what could be. She highlighted emerging technologies, neuroenhancement implants, brain-to-brain interfaces, and emotion-sensing wearables. In the near future, we may not just measure love, we might amplify it. The auditorium hushed as she played a video showing a couple using haptic suits to simulate long-distance touch in real time. Another showcased couples engaging through synchronized neural headsets, where shared meditation induced synchronized brainwaves. Connection is evolving, she said, but that doesn't mean it's becoming less authentic. Jordan stepped in to present the latest prototype of their AI relationship assistant, now capable of detecting emotional misalignment and suggesting communication tips. It's not replacing human instinct, he said, just helping people understand themselves and each other better. Back in the lab, Elena reviewed long-term data on couples who used the assistant. Surprisingly, the ones who leaned on it less over time had stronger relationship satisfaction. Tech was a bridge, she noted, not a crutch. Thank you for watching full video. Now don't go without like and subscribe.